Good morning. One more example I'm going to show you. These steps you already know. That means we are going to design a 3-bit synchronous up counter. 3-bit synchronous up counter using T flip flop. Instead of J and K flip flop, we are going to use T flip flop. For a T flip flop, we have only a single input control for T. That means either 0 or 1. That if the T input is 0, it is storing the previous input, and if it is 1, it is complementing the previous output. Previous output. Okay. That means if you want to have a 0 to 0 transition, you have to put the 0 as T input. That means if you have to preserve 1 to 1, that means if the previous input is same as that of the next input, then the T value should be 0. And if you want to have a transition from 0 to 1 or 1 to 0, we should have that you have to make that T is equal to 1. Okay. That is all about the excitation table of T flip flop. Excitation table of T flip flop. This is T flip flop. And now the third step is transition diagram. That means as this is a 3-bit counter, you have 3 flip flops required, and the transition diagram is this 0 0 0 0 0 1 0 1 0 etc. like this. That means 0 to 7, then coming back to 0, again to 7, coming back to 0, like that. And this is the present state and next state. That means 0 0 0 is converted to 0 0 1. That means the output of Q2 Q1 remains the same. The output of Q0 is converted to from 0 to 1. That means 0 0 0 to 0 0 1, 0 0 1 to 0 1 0, 0 1 0 to 0 1 1, and like that. That means I have completed the table. That means once that 1 1 0, after 1 1 0, you have to clear the input to zeros. That means here, unlike asynchronous counters, in a synchronous counter, every flip flop or each and every flip flop is triggered by a single clock pulse from the same source. Now, for this to happen, that means for us to have a counter like this, now the T input has to be generated. What should be the T input? That means for flip flop T2 flip flop 0, 1 and 2, there are 3 T inputs 0, 1 and 2, and for each input has to be generated. That means T input of each flip flop has to be generated. Okay. Now the T flip flop is, that is here from 0 to 0 transition. Q2 is, that means from 0 0 0 to 0 0 1. This Q2 remains the same. That is why you have T2 equal to 0. Here 0 to 0 transition, again the value is 0. 0 to 0 transition, again the value of T is 0. And here 0 to 1 transition, that is why here T input is 1. Again 1 to 1 transition, 1 to 1 transition, 1 to 1 transition, and here there is a 1 to 0 transition. So here 3 zeros and after that 1, and likewise we have completed the T inputs. So this is T2, T1 and T0. Now we are going to generate combination circuits for T2, T1 and T0. For that, I have written the truth table for, this is for T2, this is for T2, this is for T1, and this is for T0. Okay, that means when Q2, Q1 and Q2, Q1 and Q0 0 0 0, what is the value of T0 0 0? The T2 value is 0. That is why I have put here 0. Then 0 0 0 0 1 0. Then what about the value 0 1 0? 0 1 0 is again 0. 0 1 0 is again 0. 0 1 1 is 1. 0 1 1 is 1. So you know how to create that Karnoff map and the transition diagram, like and Karnoff map, and how grouping can be done. So I'm going to have a group like this. Here 1 and 1 have created a group, and here this is Q1 Q0. That means T2 is equal to T2 is equal to Q1 Q0. That means this row. Now what about T1? Here I am going to have a group like this. Here this Q2 has gone and the other one which has gone as what? 0, 1 to 1, 1. That means Q1 also have gone and what remains is Q0. Q0, that is T1 is equal to Q0. And what about T0? T0 is this is the whole thing is a group. So here T0 is equal to 1. T0 is equal to 1. Now I'm going to have three flip flops. Flip flop number 1. This is flip flop number 2. This is flip flop number 3. This is the output of this is Q0, this is Q1 and this is Q2. Now a common clock is applied. This is a negative edge triggered one. Okay. This is now you have a T input here. This is T0. This is T1. This is T2. T2 Q0. Now this is the clock. Okay. Now what is T2? What is T2 is Q1 Q0. Q1 Q0. That means ANDing of Q1 and Q2. That means you have taken this Q1 and Q0 here. Both of them are ANDed using an AND gate and that is given as T2. T2 is equal to Q1 Q0. Then what is T1 is equal to Q0? T1 is equal to Q0 means you have taken this Q0. Okay, that is T1. And what is the value of T0? T0 is equal to 1. Here we have 1. So we have completed the generation of 3-bit synchronous up counter using T flip flop. This is the output. Okay.